Chapter 14, Introduction to Measurement, Statistics, and Quality, Part 1 of 2. Questions that we'll answer in this video. What are the two most common types of measurement systems? How are numbers expressed in scientific notation? What's the difference between a data's mean, median, mode, and range? What is standard deviation and how is it calculated? Why do engineers control the quality of a product? And what statistical methods are used to evaluate quality? Standard system of measurement. A lack of standardized measuring instruments would not be a big deal if all measurements were done by only one individual working independently. In the 13th century, King Edward I made one of the first steps toward a standardized measurement system when he ordered a permanent measuring stick to be made of iron to serve as the standard yardstick of the kingdom. The king declared that a foot would be equal to 1/3 of the yardstick and that 1/12 of the foot would be an inch. The U.S. still uses this system of measurement that was developed more than 800 years ago. Today's measurement systems. The two common measurement systems are the U.S. customary system and the metric system. In this class, we'll use the metric system. The metric system, also known as the International System, or SI, was developed in France in the 1790s. It is a base 10 measuring system, which means that each successive unit is 10 times the size of the previous unit. In the metric system, different prefixes are used depending on the size of the measured value. Here's some of the prefixes. Pico, and then here's the decimal equivalent, and then basically nano, micro, milli, centi, deci. If it's just regular, there's no prefix. Deca, hecto, kilo, mega, and giga. Scientific notation. Scientific notation is a method used to write very large or very small numbers in a more concise form. The method expresses a number between 1 and 10 and an exponent or power of 10. Another way to think about scientific notation is that the exponent provides information on how many places in which the direction to move the decimal. A positive exponent moves the decimal to the right, whereas a negative exponent moves the decimal to the left. Zeros are used as placeholders. Conversion factors. Use the following method to convert between units. As an example, convert 160 kilograms to grams. So we're going to start with what we know, 160 kilograms, and then we're going to put 1 kilogram on the bottom. 1 kilogram is equal to 1,000 grams. After we have our conversion factor set up, this is our conversion factor right here, we're going to multiply across the top and divide by the bottom. So 160 times 1,000 divided by 1 gives us 160,000. Now watch what happens to the unit. The kilograms will cancel out because I have 1 on top and I have 1 on the bottom, and the only unit I'm left with is grams. So in 160 kilograms, there are 160,000 grams. Try this practice problem on your own. Convert 1.2 kiloliters to liters. Basic statistical analysis of data. Statistics can be described as the collection, analysis, and interpretation of data. Mode. The mode is the numeric value that occurs within the greatest frequency in a dataset. A dataset with 2 modes is called bimodal. A dataset with 3 modes is called trimodal. Median. The numeric value in the middle of a given dataset arranged in numerical order. Mean. The mean is the average. Calculating standard deviation. The standard deviation of a dataset is a value that indicates how close the values are to the mean value of the dataset. A small standard deviation indicates that the data values were close to the mean, whereas a large standard deviation indicates that the data values are far from the mean. The standard deviation formula is this. Standard deviation equals the square root of the sum of x minus the average squared over the number of trials minus 1. Quality. The importance of quality is sometimes dependent of the intended function. The quality revolution. The explosion of the quality revolution started in Japan after World War II, when manufacturers of military goods switched to producing consumer goods. They solicited the help of Dr. W. Edwards Deming and Joseph M. Juran, 2 American quality experts. And by the mid-1970s, Japan's reputation for producing quality automobiles and electronics began to surpass that of the United States. Quality Management System. Joseph Juran developed a quality management system known as the Juran Trilogy, which enables manufacturers to achieve the intended results. Quality planning, decide what cookie to make and assemble the necessary ingredients, kitchenware, and appliances. Quality control, while preparing the batter and baking the cookies. And finally, quality improvement. Evaluate the cookie to see if it meets expectations. On reflection, you may identify ways to improve the cookie. Different improvements may include speeding up or reducing waste. Quality planning. Step 1, establish the product. Step 2, identify the customers. Step 3, discover the customer's needs. Step 4, design the product. Step 5, develop manufacturing process. Step 6, develop the controls and transfer them to operations. Establish the project. Establishing the project involves two parts. 1, identifying what the product will be, and 2, assembling a product team whose members have defined roles and responsibilities. Identify the customers. To ensure a successful product launch, the project will need to identify the potential customers. The project team should include market research, members who can identify potential customers and determine what they are willing to pay for a product that meets their needs. Discover the customer needs. Once potential customers are identified, the next step is to discover their needs. These requirements will include what the product should look like and what customers like and dislike about the products currently available on the market. Design the product. A good design will make it easier to manufacture the product and will result in increased output and decreased waste from rejected parts. To achieve a good design, a designer or engineer must have a good understanding of the process that will be used to manufacture the product. Develop the manufacturing process. The next step in quality planning is to develop the manufacturing process, or a series of actions or operations that will result in the production of a product. The appropriate tools, tasks, and suppliers of materials are identified. Develop the quality controls and transfer them to operations. There are many types of quality controls, such as the development and implementation of standard operating procedures. Quality control. Producing a quality product does not stop at the planning stage. To make a manufacturing or production process stay in control, an inspection process is typically implemented. This can take the place at the end of the production process or throughout. Inspecting throughout the process is preferable and can take many forms, such as destructive testing, where the product is destroyed and analyzed, non-destructive testing, and basic measurement. Quality improvement. The last step of the Juran Trilogy is quality improvement. This ends part 1.